Exercise 6. Develop a math model for the problem. Describe the type of math problem that has resulted. Using assistance from the TI-Nspire CAS, solve the math problem and interpret the solution. A college cafeteria wants to create a hearty, nutritious, and economical granola breakfast cereal by blending two brands. Brand A granola, which costs $4.09 per box, and Brand B granola, which costs $5.99 per box. To be hearty, the cereal blend must have at least 180 calories. To have desirable texture, the cereal blend must have at least 11 grams of the relatively crunchy Brand A. To be nutritious, the cereal blend must have no more than 0.80 grams of saturated fat, no more than 50 milligrams of sodium, and at least 6.0 grams of protein. How shall the blend be composed such that the cost is minimized? The nutrition fact labels are provided, round the cost to the nearest cent, and record the amounts of Brand A and Brand B in grams rounded to the nearest gram. Okay, how to start? Well, a couple variables come to mind would be Brand A and Brand B, and since the question ultimately asks the answers to be recorded in grams, you might think choosing variables to be the mass of Brand A and mass of Brand B, but I don't know. Take a look at the information we're going to be working with, the nutrition fact labels, and if we look at what we got here, you notice a nutrition fact label, all the information is based on one serving. The serving is the key behind the nutrition fact labels. And since we have so many nutritional requirements here, we might do real well to use a number of servings of Brand A and number of servings of Brand B to be our definition of variables. So let's try that out here. Let x equal number of servings of Brand X granola, Brand A granola, and we're letting y equal the number of servings of Brand B granola. Alright, now the key quantity, the quantity we really are most interested in here, is actually the cost of this breakfast. Of course, we'd like to make the cost cheapest, so let's go ahead and define C to equal the cost of the granola blend, we might call it. And let's try to formulate that if we could. What do we know here? The only cost information is up here. We know Brand A granola costs $4.09 per box, and Brand B granola costs $5.99 per box. However, we really need to have this in terms of servings here. How are we going to do this? Okay, let's take a look at that nutritional fact labels. Okay, up in the top, say the Brand A label first of all. You notice it defines a serving size, what its serving size is. Here it's 3/4 cup, 52 grams. And then, importantly, for what we need now, it tells us how many servings are in a box or container. In this case, it's about 7 for the Brand A granola. Okay, so if the box is $4.09 and there are 7 servings per container, this tells us how much one serving is. One serving would be the $4.09 divided by 7. Similarly, we can look at the Brand B granola box nutrition fact label, and it defines its serving size, 1/4 cup, 30 grams. See, it depends on the manufacturer how they're going to define their serving size. It's all different. But here, this box says that the serving per container is about 11. Okay, so this is the information we need to figure out how much the price is of one serving size of Brand B. That'll be that $5.99 divided by 11. Okay, this means we're in a position to formulate our cost function. Okay, so we're going to take the cost per serving of Brand A, and now let's I guess we can stay in dollars. Okay, so we'll say 4.09 divided by, remember that was 7 servings per container, Now that's the cost per one serving. If we have X servings on our blend, we need to multiply that by X. And then there's cost due to using the brand B, and the cost per serving is the $5.99 divided by those 11 servings per container per box times Y servings. Okay, there we are. So this is important here that now we've got ourselves formulated an objective function, the function we're trying to work with here. And we might remind ourselves we are trying to minimize this. Okay, and let's talk about the domain. Subject to. Okay, first thing we have, as usual, is that physical sense idea. Alright, can't have negative numbers of servings, right? Doesn't make sense. So you could have 0 of something and positive numbers, but that's it. Alright, so we formulate that by saying X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. There's our physical sense, and we could number that as inequality pair number 1. Let's see, what else have we got? Actually, while we're on this physical sense idea, there was something that was kind of related to this. It goes back to here. To have a desirable texture, the cereal blend must have at least 11 grams of relatively crunchy brand A. Okay, this is maybe a good time to formulate this because it really ties into this physical sense here. It's restricting the amount of brand A only in this requirement. Now, how are we going to formulate this? All right, we need to have at least 11 grams. Okay, in terms of servings, what would that be? Okay, go back to that nutritional fact label. Now, in the brand A, the serving size there in the top is defined as being 52 grams. Okay, that means we can talk about the 11 gram requirement as meaning 11 divided by 52 servings. Okay, so this one here require 11 grams of brand A. Okay, that translates into an X greater than or equal to 11 over 52. Okay, good. Let's see. What is next? Let's scan down here. Alright, here's a sentence that looks like it has information. To be hearty, the cereal blend must have at least 180 calories. Okay, so we have must provide at least 180 calories. Little technical point here. The word calories must be capitalized in this case because in this rather scientific sense, the capital C means these are really kilocalories, and that's why you have to use the capital C there. Okay, let's proceed. How about this though? Well, we need to go back to that nutritional fact label and see what these brand A and brand B have as far as calories in one serving. Okay, there up towards the top of the label in the brand A label, you see the calories for one serving, 210. In similar position on the brand B nutrition fact label, the calories for one serving is 140. Okay, so now we can talk about how many calories are in our entire blend. We know the per serving amounts, so we can say here 210 calories per serving of brand A times X servings of it, that's the brand A contribution to calories, plus 140 calories per one serving of brand B times Y servings. Alright, now there's our total calories on our blend to be at least 180. This means we need to have this be greater than or equal to 180. Alright, that could be, let's see, here's inequality 2, the 11 grams of brand A. This we could consider inequality 3. Alright, now although we're planning to use a TI-Nspire later on, there's not really too much necessity to make simplifications, but when they're really easy, it can even make the keyboarding easier on the calculator. Here, both sides divide by 10 instantly, so let me take advantage of that. All right, 21x plus 14y greater than or equal to 18. Now, thinking ahead to using TI-Nspire, if we're going to start graphing inequalities like this here, two variable types, we do need to actually have y solved for to have a useful type of graph in formulation. So maybe we should do that right now while we're on this. And let's see here. So subtract 21x from both sides, then divide both sides by 14. We would have y greater than or equal to 18 minus 21x divided by 14. Okay, that could be 3a. An inequality derived from the fundamental inequality 3 there. Alright, what else have we got here? To be nutritious, the cereal blend must have no more than 0.80 grams of saturated fat. Okay, what to do there? Take a look at the nutrition fact labels. Alright, the concern is the saturated fat. Careful here, not the total fat, saturated fat. And there in the brand A, we see that for one serving, there is 1 gram of saturated fat. Looking at the brand B, the saturated fat for one serving is 0.5 grams. Okay, now then we can formulate for our entire blend here. Okay, first, what are we doing here? We're translating this sentence here, and that's that must contain no more than 0.80 grams of saturated fat. Unhealthy. Okay, translating that, as we had just looked at the nutrition fact label, it was 1 gram per one serving of brand A, so that would be 1x plus, and it was half gram per one serving of brand B times y servings, and we'll need that to be less than or equal to 0.8. Okay, now that's inequality number 4 there. And let's see, as far as this goes, you probably want to multiply both sides by 2, perhaps by 2 to get rid of at least the 0.5 here. So then we could say this could be 2x plus y less than or equal to 1.6. Okay, so up here, this is 4 up above. And let's solve for y, because that's going to be needed for the future TI-Nspire. And easy, just subtract 2x from both sides. Y less than or equal to 1.6 minus 2x. And this can be our 4a. Alright. Are there other requirements? Yeah, this same sentence said the cereal blend must have no more than 0.8 grams of saturated fat and no more than 50 milligrams of sodium. Okay, another healthy requirement there. Okay, what to do with that? Nutritional fact labels. Let's check out the sodium for the brand A granola. In one serving, 80 milligrams. In the brand B, the sodium for one serving, 25 milligrams. Okay, take this information and we can formulate. Must contain no more than 50 milligrams of sodium. Alright, so we just saw in that nutritional fact label that the brand A has got the 80 milligrams per one serving, so 80 times X for the overall contribution from brand A, plus 25 milligrams, one serving of brand B, times Y servings of brand B gives its total sodium contribution, and we have to keep this sum less than or equal to 50. There's our fifth inequality. Both sides divide by 5. I guess it just takes a minute, and it might make keyboarding a little bit easier. So divide both sides by 5. Okay, so let's see, that gives us 16x plus 5y less than or equal to 10. We do need to get y solved for, so let's go one more step here and have y less than or equal to, let's see, we'll take the quantity 10 minus 16x and then divide both sides by 5. This can be our 5a inequality there. Okay, let's see how we're doing here. Another requirement, and this is the last one. We have to have at least 6 grams of protein. Okay, so one more thing here. Must provide at least 6.0 grams of protein. Okay, need to check the nutritional fact label for proteins for each of these. Okay, and the brand A, it's on the bottom there. Okay, 4 grams of protein for 1 serving. Brand B, not as far down because actually the brand B nutrition fact label is more complete. These fact labels usually also talk about the recommendations for a daily requirement for 1 person. Okay, so for the protein in brand B, it's 6 grams for 1 serving. 4 grams on 1 serving of brand A has us saying 4 times x plus the brand B at 6 grams for 1 serving, 6 times y for total contribution. And now we have to make sure this is at least 6 grams, so we need here to say greater than or equal to 6.0. Okay, looks like we should solve for y. Maybe divide both sides by 2 and then solve for y. Alright, so both sides divide by 2 evenly. 2x plus 3y greater than or equal to 3. Can solve for y. We'd have to subtract 2x from both sides, then divide both sides by 3. We have y greater than or equal to the quantity 3 minus 2x divided by 3. Alright, here was the fundamental. I'll label that as inequality 6. Here's a derived version of it. Call that 6a. Now, that seems to be everything accounted for. Let's take a look at so here's our math model then, starting from the let x equal, defining the variables and everything that follows. What have we got for a math model? Alright, we are optimizing this function c here. This function is linear, right? Constant multiples of x and just constant multiples of y. Alright, linear function. The domain, the allowable xy's, is defined by, got this big system of inequalities. If we check each inequality, each one is linear. Okay, and each one is not only linear, it's also of the 3 allowable types: less than or equal to, greater than or equal to, or equal to. There were no equal to cases here, but those are the 3 allowable types. That qualifies this as a linear programming problem, and that is one of the questions asked for, and this is to see what you have for a math model. So right here, a partial answer to this question, and that's that this math model is a linear programming problem. Okay, so I kind of put that in a circle there. Now, having said that, this puts us in a position to be able to solve this with the TI-Nspire. But you know what? Before we go further, and look at this math model, it's not like so simple, right? There are, we got like these 6 inequalities. When the Nspire graphs a single inequality, it draws the boundary line and shades to one side of the line. If we are to solve the system, we need the intersection of all of this. Now that would be like the darkest region amongst probably quite a few. Alright, that might actually be kind of hard to see when there's so many. I find that when you get more than about 3 inequalities going, a system of 3 inequalities, it's helpful actually to sketch the complement of each inequality, and then you look for the white region, which has not been shaded at all, and that is actually the solution to your system. So you're kind of like taking the complement of everything, and you're shading what's not in the domain, and anything that emerges unshaded is actually the domain, and that's a little easier to see in a complicated case. So in this case here, here's what we can do. Now these first physical sense ones, these together sort of required we're in quadrant 1. Okay, so I kind of like just say that separately. Okay, so we are in quadrant, then the first quadrant, or on the axes of the quadrant. Okay, one of those two cases here. Make a note of that. Then we'll start graphing complements, all the remaining 5 inequalities here. For instance, this one here, x greater than or equal to 11 over 52. Now, to keep from getting confused, and it would be very confusing if you just tried to remember to graph the complement in each case, no doubt at one point you forget you do the wrong thing. So what I do is I actually make a very careful note of what I'm going to do in a contrasting color, and making it clear that it is a complement. So in other words, if x is greater than or equal to 2, what's not the case? Not x less than 11 over 52. And this is, I'm going to be graphing the reds as I look through my own work here to see what to do in the calculator. Now, this one here, if you're graphing this, the complement is to say not y, okay, greater than or equal to, less than 18 minus 21x divided by 14. Okay, this one here, to graph what's not in this restriction, y then would be greater than 16 minus 1.6 minus 2x. This one here, let's say y less than or equal to, so in other words not y greater than 10 minus 16 x divided by 5. Alright, and this last one here requires that y be greater than or equal to this, so we will exclude y less than 3 minus 2x divided by 3. Not that. Okay, so do all of this, and whatever is left over is unshaded is the domain, or the feasible region in this question. Alright, we are ready to go to the calculator. Alright, here we are. So let's open up a new document and add a graph. Now, before we do anything else here, we might consider that this question ultimately asks us to get the cost rounded to the nearest cent and the amounts of brand A and brand B in grams rounded to the nearest gram. Well, that kind of rounding might very well be 2 or 3 significant digits, which means we don't want to have intermediate rounding. We need to have fairly accurate data going into those final roundings. So the first thing would probably be to go to our settings menu here first and make sure we've got ourselves like 5 significant digits on everything, at least getting started. So here in the settings, let's get the graph. We're in the graph application. Let's make sure these guys are in order. Okay, now we want to do more than 3. We want to get to about 5 so that we don't have intermediate rounding. And actually there's another little issue here. Now in good graphing, of course you label every single graph with its equation and that kind of thing, right? Okay, now in this case, if you only have the calculator, and consider what we have going on here. We're just about to graph like what, 5 different boundary lines, this kind of thing. We would like to find vertices, which we really must label clearly. And with all of this on this rather small calculator graph, that's just too much. We're going to just be buried in writing and text and that kind of thing. So I would suggest coming in here and hide the plot labels for right now. So we'll make a suitable graph on the calculator to get the calculation performed. We have to eventually move on to a spreadsheet is phase 2 of this, but let's at least start with just a calculator graph that is functional, and then go to the computer view, computer mode, to get a large screen and draw a really nice graph that you would want to show to your client. If you were solving this for somebody, you want to have all your graphs labeled, very professional, but that would really need to be done on the computer mode in this case with so much going on. Okay, so we have this graph setting in order, and what about the general settings, because we're also going to use a spreadsheet that's going to perform calculations. Okay, the general settings, we have 6 significant digits going here with a float 6. That's good to go then. We'll just leave that alone. We're fine. Okay, let's go to our current document. We were here. Okay, let's think here. We mentioned in our model we have got ourselves entirely in the first quadrant, right? And another thing to consider is that we are actually creating this breakfast, a cereal breakfast, which means how much do we realistically expect to be having come from each of these 2 granola sources? Well, probably not any more than 3 servings from each one. Otherwise, the breakfast itself just becomes unrealistically enormous. So maybe we can start by setting up a coordinate system that's kind of reasonable to what we have here. You don't have to do this, but it can just make things a little easier to start. So let's go to the Windows settings. I like to make sure that there's a little room for the y-axis and then some. So for x-min, not quite 0, but almost. How about negative 0.5? Oops. Okay, negative 0.5. Tab. For x-max, let's say 3. Scaling 1 per unit. Y-axis, same idea. Negative 0.5, and let's go up to maybe 3. And scale it 1 apiece. Alright, this kind of gets us started with a reasonable coordinate system. Okay, now let's look at our situation here. We know we're in quadrant 1. Okay, that's something we will just kind of remember as we get to the end of this. We are in quadrant 1, or on the axes bounding quadrant 1, perhaps. Let's look at our second inequality there. We were going to graph x less than 1150 seconds. Okay, the boundary line for that is the x equal to 1150 seconds. That's a vertical line. Okay, we can't graph a vertical line by using this entry line here. This is only for functions and relations where y is solved for, not an x equal to a constant, not a vertical line. How do we do this? Okay, well, we can construct a perpendicular to the x-axis. That's how we can get a vertical line. So I'm going to escape the entry line here, and now let's go to the menu and let's go to construction. Let's go to perpendicular lines. Alright. Now, by the way, when you've selected a tool, perpendicular lines like we've done here, in case you're wondering, how do I use this thing? You kind of don't know what to do. You can go up to the icon for it, and just hovering over it will give you some instructions. Okay, so here it says perpendicular. Click the line, then the point through which the perpendicular should pass. Or enter a parenthesis and then coordinates. Okay, well, what should we be doing? Consider what we have in mind here. We are trying to get 5 significant digit accuracy on our results here before we go into a spreadsheet. Alright, so we don't need a vertical line that looks okay. We really need to peg this at x equal to 1150 seconds. So we're going to take advantage of entering these coordinates after we first select our x-axis as the line. So, x-axis, there's our line. Now, as those instructions said, I do a parenthesis, and what do I want for this x-coordinate? Alright, here's where we do the 11 divided by 52. Okay, hit enter. What about the y-coordinate? Okay, this point can just be on the x-axis, of course, so that makes a y be 0. And enter. Okay, nice. We've got our vertical line there. Now, since we're all done with this perpendicular tool, let's push escape to put away the tool. Alright, so here's this vertical line. It's pretty nice. However, it's a little short. Like if we have activity up here, we're not going to see what's going on. Okay, no problem. You can just come over here, push down, and then pull this up. There. Now we have a nice long line. Another thing, this line it could be rather important in our future domain here. So I don't want it to just be that little light black. It starts to look like a coordinate axis, not very prominent. I want to make this thing really prominent because it could very well be critical. So I'll put it in red. All right, there we go. Now we have that. Okay, now that we have that, let's go on to the next inequality. We were going to graph the y less than 18 minus 21x over 14. So it's time to tab to bring in the entry line here. And now let's see, we need to delete that equal sign. We have in mind an inequality, a less than, number 2. And now our formulation, parenthesis 18 minus 21x, parenthesis, divided by 14. Okay, that looks alright. We'll go with enter. Alright, nice. Now remember that deletes that portion as being possibly part of the domain. We're graphing all of the what can't be in the feasible region right now. Alright, let's go to the next inequality here for us, and we'll need to push the tab to bring up the entry line again. Let's delete that equal sign. This time it is a greater than inequality we're graphing. It's number 4. And then we have here 1.6 minus 2x. Okay. By the way, and just a little item here. Now you notice I just put 2x together. Now I know I can get away with that because a variable cannot start with a number. So that has only one interpretation as 2 times x. If you have like a x times y or something, you have to put the multiplication sign between them. Otherwise, the Nspire doesn't know how to interpret that, and you get errors and create headaches for yourself. Some people just make it a habit of putting multiply between any multiplication. They never use the juxtaposition as I've done here. However, if it's just 2 times a variable or a specific number times a variable, you can succeed doing this, and it's actually a little faster, but you just have to be a little more careful. It's up to you, but it was something to think about. Okay, let's hit the enter key here. Wow, okay, just deleted a lot more of the xy plane as being possibly in our domain here. Okay, let's go to the next inequality. We need a tab to get the entry line, backspace to delete the equal sign. The next one is a greater than, that's 4, and let's see here, we have got a parenthesis and 10 minus 16x parenthesis and divided by 5. Okay, enter. Alright, more deleted xy plane. Okay, and we still have another inequality to delete more xy plane with. It's the last one down here. So let's tab, bring up the entry line, and delete that equal sign. And this time we need to be less than. Okay, in the parentheses, we got the 3 minus 2x parenthesis, and to be divided by 3. Alright, all of this. Now, a couple things to remember. One, we are in quadrant 1 or on the axes due to those first physical sense requirements. A second item, also very important now, is remember, we drew this vertical line and we know we have to exclude anything to the left of it. So we have to mentally keep track of that. And that means right inside here, this little white region is actually our domain here. Okay, it's so small. Let's, of course, do some zooming in. So I think I will use the zoom box. I like that one. So for the corner, I would like to try to keep the origin. Call that one corner. And let's kind of come out here enough to get it and enough to have some room, but not excessive. Okay, maybe there. All right. Now, as it turns out, our oh, and by the way, now that we're done with the zooming tool, it's escape time to get rid of that. Okay. Now, this line actually is still not long enough. All right, I'll bring it back up there. There. Okay. So now we see what we need to do. We need to get a hold of this region here. Let's make it more clear. Here's what I'll do. I'm going to start getting the vertices all on here now. Okay, for instance, if we start, say, here, this is going to be an intersection of two boundary lines. Okay, so we can come here to this graph. We can select Analyze Graph and an intersection. Analyze Graph, intersection. Okay, now the second graph could go here, and then a lower boundary, maybe there, and then an upper bound as you start to glide over. There, the intersection appears. It's time to hit enter. And now you have that. Okay, let's move this text onto our graph more clearly. Let's see, I think about there perhaps. See, there's going to be quite a bit on this graph, right? Okay, let me see, maybe up there. So I'm thinking about that other vertex already is needing room for that. Okay, let's try to get this vertex that's right about there. So we could take this graph, first of all, analyze an intersection, and then go to this as second graph. There could be a lower bound. Glide over. Okay, intersection appears. Hit enter. Let's make the text on our graph. Okay, I guess right about, let's say there. Okay. Now, let's see. Let's take this blue line and green line intersection. So on this graph, let's say we plan to analyze and do intersection. And then on the green graph, we'll call that the second graph. Let's move over a little bit for a lower bound there. Now we start gliding over for the upper bound and watch for the intersection to appear. There it is. Hitting enter. Okay. Let's see. Let's put this on our graph. Okay. Right there. Looks... Wait, let me keep it out of the region itself. Okay. Up there. That looks pretty good. Alright. Now, we got these two other vertices there and there. Now, this is a different situation. You can't use the Analyze Graph Intersect because this vertical line did not result from something out of the entry line there, formulation, the f of x equals 2 or y less than. It's not one of those cases, so it will not interact with the Analyze Graph Intersect function. Got to do something else. Let's see, what could we do? Okay, here's an idea. This graph, let's first trace it. Okay, tracing trace graph. Okay, so see the tracers on that graph. Now, what we want is, we want to know where that graph hits that vertical line. Well, what we do is we will input that x number right now. Now, remember, if you don't remember, just look on our back on our development, our formulation. That's 1150 seconds. So I start just typing 11 divided by 52. If I push enter, it'll put it there, and down there in the lower right you see the coordinates. Now I need to put enter again so that it actually labels that point with those coordinates. A more permanent situation. Okay, there. Now we got that. I think we're still organized. That point is very close to the point that we have traced there. Let's go ahead and move. Okay, now here's another graph that I would like to trace. It's the green line, and I know I'm tracing the green line because I can see the green lower right font. Okay, so now we are tracing. We can put in the 1150 seconds here. Now it might actually still retain the 1150 seconds from the previous trace, but I'm just going to make double sure that by 11 divided by 52. 2 and entering. Okay, that is the case. Now I'll push enter again to get that labeled there. Okay, now I'm going to hit the escape key. I'm done with this tracing thing. I want to get more organized on this part. So let's take this, move it over there. Okay, and this, let's move this over here, about there. See how we have so much on this graph? Imagine trying to put the labels of all these boundary lines here. It would look totally chaotic, probably. All right, now to make the feasible region very nice and clear, I am now going to delineate it and shade it with bright red. I think that stands out the best, and I eventually would like to erase all the other colorings in this in a second phases, but just for right now, let's just get the feasible region at least prominent, and that would be good enough to proceed forward. Alright, so how can we do this? Let's do this. Let's go to this menu and get a no, it's a shape, a polygon. Okay, here we are. Now we'll start there, the point on, up here, point on, over here, intersection, don't do point on, make sure you get your intersection there, intersection, and here an intersection, and then we need to come back to this special point on. There. Great. Now we've delineated the feasible region. Since I'm done delineating, constructing, I'm going to escape to put away the polygon drawing tool. And now I'm going to grab the polygon here, and I want this to be very prominent, so I'm going to come up in color. I'm going to fill it with bright red, and I'm also want to make sure its outline is bright red. So another color, line color, and make that red also. Okay, there we are. Now, in case you only have the calculator and there is no computer version for you, here's something else you can do to at least get this much clarified on what you've got here. Alright, labeling that feasible region as the feasible region. Let's go to the text tool here. And we could say, let's see. Now this, if I can put the text inside the feasible region, that is great. But here the feasible region is rather small, and my text is rather large, so I will just describe instead. So feasible region is the red polygonal region. Okay. Just move that over. It's kind of like the bottom title of the graph there. Okay, that looks pretty nice. We're ready to go to a spreadsheet to tabulate the value of the cost at each vertex, right? A linear programming problem. Okay, so for this, it's time to add a page. So control, add page, and we're thinking spreadsheet. Okay, let's see. In this column, we can put the x-coordinates of the vertices, and we can give this a name in case we want to do a calculation later on, and we will. So I want to give this a variable name. Don't use just x. That's too simple. It causes troubles for the other applications. So let's call it x vert, for example. Tab forward, and similarly, let's call this y vertex. There. Here we could put the cost. Right there. Okay. Now, we need to start putting in the data here. Okay. To do that, it's basically cut and paste. Ready? Back to our graph. Alright, let's kind of keep organized. Alright, let's agree to start on the maybe this lower right-hand point and travel around till we get to the point 333 x-coordinate one there. Okay, so starting here, double click. When it's blue, you can Control C to copy it, and then go back here and Control V to paste it. Okay, and then you can go here, prepare for the Y coordinate, back to the graph. Okay, 2 clicks, it's blue, ready to copy. The Y coordinate, Control V, it's there. Alright, now we're here, go down here, a new point, go here, 2 clicks, see blue, copy, Control C. Back to the table, right there, Control V. Over here, that'll be next. We double click, make it blue, copy. Back to the table, Control V to paste. Okay, third point. That would be here. By the way, here's a little shortcut. Notice these next 2 points have the exact same x coordinate. That's the 1150 seconds. So this one I will actually paste twice to save a couple seconds of work. So first, double click, make it blue, copy it, and then Control V. It's there, and while we're at it, Control V there as well. Okay, let's go back, get their Y coordinates. Double click, ready to copy, Control C. Back to the table, Control V. This will be next. Back here, double click, Control copy, and Control V paste. Alright, lastly here. Alright, double click, copy, and paste. Here, double click, Control C to copy, and paste. Okay, all our vertices are now in the table. Great. Now we want to compute the costs at each vertex. Alright, now in the spreadsheet, this is the labeling bar here, this first one. Down here is a formula bar if you intend to use that. Alright, in the case of the cost column, it's going to be controlled by a formula. Click here, double click here rather, to get ready to put our formula in. So what's the formula for cost? We go back to our own formulation. Now our formulation was 4.09 over 7 times x plus 5.99 over 11 times y. A little careful here. Don't use x and y. In this table, we have there's actually 2 choices you can use. Since we had labeled this x vertex, we can use x vertex as the x, or even simpler, is just the a. So this column matrix here has 2 possible names for us. A, which applies only in this spreadsheet and not to other pages of this problem, and the x vertex, which is actually a variable we can use throughout any other page of this problem for hereafter. Alright, since the a is simpler to use, I actually use the very simple notation just for within this spreadsheet. So this means, here comes our cost then. We have got our 4.09. Now instead of that x, I'm putting the a. And by the way, small case, large case are indistinguishable in the world of the TI-Nspire. So that's the same as that capital A that labels the column there. And what about that? It's to be divided by 7. Okay. And now there's a plus. And the 5.99. Now here's what I'm going to use, the B. Okay. And then that's to be divided by 11. And notice in the bottom of this is the our formulation, very clear, not cut off like what's going on in this box here. So now I push enter. Okay, here we are. Now we just have to look around for our conclusion. Okay, look at this here. We're looking for the lowest cost, right? So I just have to size up which of these numbers is the smallest, and the 0.62 looks like that's us. Okay, now this was in terms of dollars, so this is 62 cents. Remember, we're rounding to the nearest cent. And what's over here in the x and y? Now this is the number of servings of the brand A. This 0.77143. That's the number of servings of brand B. Now, when we record our final answer, the question wants us to talk about number of grams of brand A, number of grams of brand B. All right, no problem. We can work with that. Let's get ready to write a conclusion on a notes page. Now, the first thing we're going to do on the notes page is first figure out how many grams of brand A, how many grams of brand B. It's actually a little bit of a calculation. We want this number here, right? That's the number of servings, and we want to multiply that by the number of grams in a serving of B. So it's going to be referring to the nutritional fact sheet again. Now, when we refer to this number, how do you do this? Okay, if you go to another page within this problem, now is our chance to use our xvert that we have here. Now, xvert refers to this whole column matrix here. So we have to remember that what we're interested in is see, line 2? Okay, the second entry of this column matrix is what we want for the xvert. All right, so we'll do a little computation of the number of grams of brand A, number of grams of brand B, before we even make our final statement of conclusion. Okay, we need a new page. So ready, control, add page, notes. Okay, well, you know what you can do is you can right-click here and grab go to our variable choices are, and we want the X vertex. Now, it's a column matrix, so you have to refer to its second line entry, and for that you use a square bracket, put a 2 in there, the other square bracket that goes with it. Okay, there, that refers to the X second entry. Now we were to multiply that times, okay, in case you've forgotten about what's going to go on here, nutritional fact sheet. Okay, take a look at brand A. It's right there, serving size 3/4 cup or 52 grams. Let's also take a look at the brand B when we do the similar calculation there. Okay, a serving size is 30 grams for a brand B. Okay, so here times 52 and enter. Okay, now I can make this look a little more to my interest. Math box attributes. All right, we'll make that little green arrow into an equal sign. This is an equality calculation. And okay, since we're now in the final stages of rounding, it's just as well that we display just 2 digits there. Is going to give us the nearest gram. Okay, so we have that. Now let's go down here. I think I'll just kind of clear this and proceed the same way, which is to go here and select the from the variables yvert. If you select a variable, it opens a math box at the same time, which in the notes page it allows you to do like calculations for a moment instead of just writing text. And when you select a variable, it automatically assumes you intend to open a math box, and that's why you see the little red rectangle around this, because we actually have a math box up and running right now. Now, for the xvert, we want its second entry, so it's time to get the square bracket out there. And number 2, the right square bracket. Now we're going to multiply this. Remember the nutritional fact sheet. We just got through reading it was 30 grams for the brand B per serving. So now we can go and enter, and we can make this look a little nicer here, like we did the first one. Since that was an equality calculation, make it an equal sign, and we are in our final conclusive stage, so it's just as well we just record 2 digits. And now we're ready to make a conclusion. By the way, in case you've forgotten the cost here, let's go back and look at that. There we are. 62 cents, rounding to the nearest penny, right? Okay, our conclusive statement. Therefore, a minimal cost of, okay, we can use a dollar symbol, 62 cents, can be achieved by using 18 grams of brand A and 23 grams of brand B. Alright, now this is our huge conclusion to this problem after quite a bit of work. So, although we can't put the huge prominent cloud around this, I can at least do something like this and make this, format this in bold, since this is one of the most important parts of our question here, the bottom line, so to speak, there. Alright, so now we have got all of that. That looks pretty nice there. Now, the other thing we might do here is, how can we check this over? Alright, for checking in this case here, what we like to have is this a reasonable kind of answer, sort of a check? Because remember, in an application problem, the big source of error is translating from the real world to the math model, not usually performing the math itself. Okay, so let's at least make sure that we're not way out of bounds here with our numbers. And how can we do that? Well, we could actually use the two known products, brand A and brand B, as sources for what is kind of reasonable for a serving size of a breakfast granola dish. Okay, so we could actually look back at those nutrition fact labels for a moment. Okay, now in brand A, when it talked about a serving size, it was 52 grams. Remember, brand B talked about what it thought was a reasonable serving size. It was taking like 30 grams. Okay, 52, 30, and what kind of answer have we got? When we make our blend, we're going to be mixing 18 and 23, so we're up to what, 31, 40, 41, a 41 gram serving, right? Okay, so that's the first thing we can address. So let me try to change the format to regular here. Okay. Check. Okay, according to brand A and brand B, nutrition fact labels, a granola serving may be 52 or 30 grams, respectively. Thus, the proposed blend at let's sum this up here. 18 plus 23 equaling what is it, 41 grams appears reasonable. Okay, what about that cost there? Okay, well, let's use the brand A, brand B's all by themselves as resources. What kind of cost is there associated with just an average granola breakfast? So here, maybe another line. As for a cost check, all right, let's see. A serving of brand A would be, okay, how can we compute that? Well, go back to the little bit of information we have, which was that the box was $4.09. So let's talk about cents here. We'd have, well, okay, you know what? This is actually something you don't just do this one in our head. So actually, here's a chance to bring up a math box. Okay, so we have in mind $4.09. That was the in cents the price of the brand A. And divided by how many servings was in brand A? That was, if you go back and look, it's about 7. Okay, enter there. Okay, wait, I wanted that to be a decimal number, so let me back up here and let's do it this way. We do a control approximately equals 2. Okay, and then we can take our math box and not have all these digits here. Let's have it display 2 and make that an equal sign as well. Okay, there we go. Be 58, and let's add on the unit to measure ourselves, and a serving of brand B would be, okay, let's use the brand B manufacturers as another guide to what is reasonable. Okay, let's bring in a math box. And the case of brand B is, we recall from our initial information, it was $5.99. All right, let's talk cents then. That's 599 cents divided by, how many servings did it say in this nutritional fact label were in the container? About 11. Okay, and we can say about equals to here. And then we can touch this up with attributes. Namely, make that equals to, and just 2 digits to get the cents. Okay, that looks better. And we can tack on our units of measure, cents. Okay, thus, the proposed cost of the blend as being 62 cents appears reasonable. Okay, and that's what we're looking for, at least in this kind of check. We don't have a magnitude of error problem. Something is not off by a factors of 10, like we propose a $6.20 granola blend here. Or we find that we're thinking about having 400 grams of brand A and 320 grams of brand B, something like that. This is what prevents us from saying something as crazy as that. So we want to make sure we look for that. As for detail checking, you almost pretty much have to resolve this question a second time on another day to see if you arrive at the same answer twice, because a very minuscule error, which would be very hard to notice, it only would probably be noticeable at this point by just solving the whole thing a second time, seeing if you agree with yourself in that case. Okay, so this looks okay here. The last thing would be to, if you have the computer software, to make a nicer looking graph of our feasible region, and let's maybe go try that now. So we go back here. First thing we might do is replace all of this inequality graphs with just boundary lines. Okay, so to do that, we could pick up the entry line, expand it. Now we'll start to replace these with just equal to. When you do that, delete and put the equal sign, for some reason it puts a multiplication thing there. You have to actually erase that, so go up, back, and enter. Okay, back to the entry line. Second one right here, backspace, equal sign now. Okay, enter. Entry line, expose it, backspace, equal sign, and enter. Entry line, expose it. I need to go down, backspace to delete, equal sign replaces it, delete that multiplication. Okay, so by doing that, as you see here, I've changed everything into an equality so that only boundary lines now appear. Alright, now one more thing I might as well do, since it seems to be easier done on the calculator, and that's that I'm going to go back to the settings and to the graphs and geometry. I'm going to go ahead and now I want those plot labels to actually appear. So I'm going to undo this hiding restriction and say OK. And if I go back to the current graph, there you see all the labels are all like half of on top of each other, but there they all are available to us. Okay, now at this point, this is probably a good time to go to the computer view. So view, computer. Alright, and now I will also kind of expand the size of this. Okay, in the expanded view here, you can just use the colors to determine where the label needs to go. This is green, so I'll bring it over here near to this green. Oh, the vertice coordinates kind of got moved around after the expansion. Let me tidy that up. Okay, that was there. This belongs here. This belongs here. This belongs here. This, let's see, maybe it will fit right there. That actually looks pretty good there. Okay, let's spread apart these labels. Let's see, this is this magenta one. So now I can put it over here where it's labeling yet not cluttering up the rest of the diagram. Here's the, let's see, what have we got here? The blue. Okay, that might look better. Right there. Okay, this red. Maybe there. And we were talking about this red vertical line. It needs a label too. All right, how are you going to do that? It's time to call up a text box for this. And this is x equals 2, 11 divided by 52. Okay, and that goes by that there. Now we have a pretty nice graph that has everything. I would go ahead and capture this page, and I think as far as the table goes in the conclusion, okay, let's take a look at the table page. Okay, we could capture this image. When I capture the image, I like to click on the formulation there so that the formulation appears on the bottom. So capture that. And the other thing, the conclusion page, which in the computer view, everything pretty much fits here. Just going to proofread this one more time. Alright, this looks alright. Let's take a captured page of that. Now we have a pretty complete solution and something that I think communicates the solution pretty well as well. Okay, very good. Okay, so summarizing our Nspire work, we have above the final graph with everything labeled, including boundary lines and vertices, and the feasible region pointed out as being the red polygonal region. And we got the equation for that vertical line by using text, the x equal to 11 50-seconds. Then, just below that, our tabulation summary, formulation of cost in a box there as well. And then our conclusion page where we converted the servings into grams of brand A and brand B initially, made our conclusion in the bold typeface, and then our basic check to make sure that at least this was a sensible conclusion. And we'd have to, of course, basically resolve a second time to confirm all of the small minor details of the calculation. Okay, very good. That's it.